first 6 chapters so far. So we will have a midterm examination next Tuesday in this class at the same time of our class. And over the last week, you have worked very hard to make questions and solving the problems and revise it and finalize your answers. And also you added some extra information that you like to add. So, and even Hajik solved his problems and he has uploaded his solutions and he checked his answer with the Sage and to make sure his answer is right or not. And yeah, he used his image, screen capture of camera image of his solution by hand in here, and to check his answer is same as what he got from the Sage, like this. And yeah, many of you made the solutions of the problems in chapter 6 and others to find the standard matrix, and he checked, Mr. Kim checked his solution is right. He even tried to find the same standard matrix of a given linear transformation in 2 different ways. He used this command to find the answer, and he also used the other command to find the standard matrix of the given one, given linear transformation. Okay, and yeah, I have found, yeah, you started to go through the concept of what concepts that we have covered so far, including Gaussian elimination and Gauss-Jordan elimination and row-reduced echelon form, and the relationship between row-reduced echelon form and reduced echelon form, and the relationship between the elementary matrix and elementary row operations, and the concept of row space and concept of column space, which you may see in the exam, and the standard matrix of shear mapping, and the definition of scalar matrix, and the definition of the span. Span is defined as the span of S is defined as the set of all linear combinations of elements in S. Okay. And the discussion went through further, and the definition of linear independence and linear dependent, and the definition of augmented matrix and coefficient matrix, and the definition of Euclidean inner product, which is a dot product, and Mr. Inal added some extra information on it, and linear combinations, and one-to-one mapping and onto mapping, and also the meaning of an isomorphism of a given linear transformation, and the definition of kernel and range, and the definition of orthogonal matrix. And orthogonal matrix is a n by n matrix whose inverse is transpose. And he wrote in the concept in English, and in addition to the concept, the definition in Korean as well. And the definition of linear transformation was given by Lee Ban-seok, and the concept of eigenvalues and eigenvectors were given by Ju Min-kyu. from the end of the midterm examination, from the 9th week, I will ask you to write all the keyword in the title here should be written in English in addition to a Korean keyword. Okay? Then international students will be able to participate in the discussion without difficulties. And concept eigenvalues and eigenvectors and Cramer's rules and concept of kernel were given in here like this. So if you use the Korean and English together, that will be very convenient. Okay, and Mr. Inaul, you may add those informations that you supplies in your PBL report. Okay. Mm-hmm. And I have given you the explanation of the solving problems from chapter 1 to chapter 6 on this web address. So you may see the explanation of the problems
6-4장 발표를 맡은 조재훈입니다.
on this web address. So if you find any difficulty while you are preparing your midterm examination, this site will be a good help for you. Okay, and now I will start to show you the PBL report that you have submitted, which contains the problems and solutions that you have solved. In the final, a week before a final exam, I may give you a chance to explain your problems in this class to other students who's preparing for the final examination, like what I made it for and uploaded those movie clips. Okay, anyway, this is a PBL report that you have submitted on the linear algebra class of this semester. I did the first PBL report of September. And you generally, most of you try to follow as I suggested, and tried to learn some new knowledge and methodology to deal with the new problems that you're gonna use for whole of your life. And you made your self-evaluation, right? And you recommended other students who you think deserve the recognitions. And since I gave you the movie clips of our class before our offline class, so that's a part of prepped learning methodology, and also you have solved the many problems and shared it and discussed it to get the final answer. So it's a problem-based learning. So I asked you to answer a survey, and most of you answered it in a proper way. And I have reviewed your comment to improve the weakness, and there was not much of the comment on the weakness, but this is actually the most of the content, the comment which was overlapped by you. So bulletin board, you had some difficulties, but we will find the best way, and we may give a suggestions to improve it to the system manager of the iCampus, and we will find the best way possible now. And you made your comment. You made your record on your participation weekly and total, and you made your own self evaluation on the participation part of those, and this part is also I will assign about 10 to 20% of the portion on the record of your participation based on this, and I will check all those in the system. In the midterm examination, you will see a project proposal, and then you may write your names and tentative titles and motivations and the importance of your your work, your subject, and how you can handle those problems, what kind of references and web addresses, web resources that you can utilize it, and etc. And just fill out this as much as you can, and but you don't have to really do. Not everybody have to do the project really, but I want to see how you can handle your knowledge is to deal with the subject that you have interest, that you can apply the linear algebra knowledge that you've learned. Okay, anyway, you better prepare these 2 pages. These 2 pages, fill out those forms. If I upload the final version, then it will be and then you fill out and print it and bring it to the midterm exam. Okay, then you can save your time. You can save time. Okay, anyway, so these are the kind of comments that you have made. Mr. Shin Young-jun added what he learned from the policy that I have asked you, and Mr. Ju Min-gyu also added my intention of this class that he was not clear before. And Mr. Shin Young-jun also added some information that he likes to share with you. And Mr. Jung Da-san also added some comment that he liked to share. And Mr. Hajik also wrote some comment for other international students to catch up. And Mr. Kim and added some extra information on Cauchy-Schwarz inequalities. And Mr. Lee Seung-yeol and gave a proof of one simple fact which was mentioned in the book. And Mr. Kim Sung-chan and added his understanding of a concept which was covered in the class to make sure. And Mr. Kim Do-hee and Kim Sung-chan made added their understanding in their word and made the revisions to help other students and etc. And Ju Min-gyu also added another way of showing second cosine, second law of cosine by using the Cramer's law, but this is not essential. And Mr. Kim Dong-wook added a comment that he thinks it is important. And Mr. Kim Won-kyung made a comment on the typo which he found in the book. He found, this is not right. Third law is right, so it will be fixed. Thanks. I will give some extra credit on those new findings before I find it. And Mr. Hajik added some one more extra information to be shared by international student. Okay, like this. So yeah, I supplied the way that they can handle this course without less difficulties. And Mr. Kim Sun-ho added the word that I talked with him, and also Mr. Kim Won-kyung told that the way to publish your work so it can be shared. And I mentioned that some of questions will be given in the midterm examination on the on the definitions and concept and applications of the materials that you have covered so far. So I will give you the questions like this, state or define, after I give some terminologies in English. Actually, the midterm examination will be written in English 100%. So do not expect the Korean word in the exam. And you already started to make sure that you have the right understanding of those concepts, and it was more than 20, 30 discussions went through. So, if you go through it, then you will find what you can do to answer in the midterm examinations. Okay, from now, I have added, I've collected the most of the problems that you have solved and revised and finalized, and I checked it from the chapter 1 to the chapter 6. From here, just if you have a 2 point, then how to find the vector between those two vectors, 2 points, then this is the way to find it, and Mr. Jung Jin-kyu checked it, whether it is the right answer or not. And for same problems in the with different values, and other problems, similar problems in a different pattern, and the vector calculations can be done by hand and also can be done by the code. But here, I think, who is this guy? Mr. Lee Hyun-sung? Who's Lee Hyun-sung? Lee Hyun-sung-gun? Okay. Mr. Lee Hyun-sung is not here now, but he should know he did not really check his answer by the tools. This is not bad. This is not good. So I will give a 0 point on that. Okay, and Mr. Hajik solved his problems, and he double-checked his answer with this. So this answer is same as this. So he write his answer with his confidence, and he now knows he can do the computation of those vectors with many. With much of the difficulties. And the similar problems were solved and checked, and on the chapter 1, chapter 2. So, so that's just the start. So you get acquainted with those simple computations and the simple code. Then to start with now. And now you are ready to do the real problems of chapter 1. So now you are finding the norms of vector and the inner product and Euclidean inner product of the given vectors to find the cosine theta value like this. And it was checked by Mr. Im Sang Hun and whether it is right or not. And he did even find the approximation of the value theta. In the earlier years, we have to use the kind of the sine triangular function tables of it, tables. But now, you can just use the tools to find the approximation of any values that you have. Here, he changed the numbers to find the similar problems and solutions. And here, he mentioned what he have learned while he is doing this kind of work by hand and code. And also, he used the interactive function, actually, that you're going to learn after the midterm examination in here. And those are the kind of simple computation that you know how to do it. How to find the projection, from a point to a plane. And this is the formula, so you know. Just all you have to do is just find the projection of V on to the normal vector here. So all you have to do is just find the projection of V on the normal vector, which is this. And here he found actually there was an errata on here, and he fixed it in here. And find the distance between two vectors can be found by definition. And finding the inner product is equal to 0, so we can say those two vectors are orthogonal. What's the value of A that makes these two vectors are orthogonal? And there are other approaches. And these are the similar problems here by many of you solve the problem. And this actually, you may see, find problems like this in this midterm examination. Find the vector equation of a line between 2 points, something like this. Vector equation and for the line and planes are the main idea that you have to know from the chapter 1. Actually, this problem deals with it, and he found it, and he checked those by the sage in here. And just change some numbers here and there. Find the length, similar problems by you, and find the normal vector of the given plane. What's the normal vector of this? So if you write it in this way, then you can clearly see 7 minus 1 and 1 is a normal vector of this plane. This is the equation for the planes, which is equivalent to this, whose normal vector is this. And here, similar problems. And check whether these two vectors are also normal or not. Okay, so all you have to do is to check the inner product of two. And now is chapter 2, solving linear system of equations. Find the coefficient matrix of this linear system of equations like that, and express this linear system in the form AX is equal to B, and then find this augmented matrix like this. It all can be done by the simple comment like this. And find the linear system of equation with its augmented matrix looks like this. Then from here you can find the non-homogeneous linear system of equations with 4 variables, and which matrix in You can check, you can check whether the given matrix is in the REF form or RREF form or not by doing the Gaussian eliminations. Okay, in this case, those two are clearly not in the REF nor RREF. But after you do the Gaussian elimination, you can find REF and RREF if it has similar problems that can be done by hand and by code, and the same problems, similar problems, and solve the system of linear equation using Gaussian elimination, and you do make a augmented matrix and do the Gaussian eliminations to have the REF or RREF form to get the solution of the given equations. But in this case, since the last equation, which is 0W is equal to 1, which is not true, there is no W that satisfies these equations. So the whole system cannot have a solution. It can be easily checked by finding the REF and RREF of the given augmented matrix, and solve the system using the Gaussian elimination. You do it by hand in this way, the same problems. Okay, and now solve the system by Gaussian elimination, and you can do it, and you can find the augmented matrix, RREF form of augmented matrix, then clearly this says x is equal to 1, y is equal to 3, g is equal to 1. You can do it easily. And also, with this code, even though you have a very large size matrix, augmented matrix, you can easily find the solution of it, if it does exist. And some applications on the circuit, and then also, you can find, you can form the system of equations to have those current by using the Kirchhoff's law. What else? This is a problem that finding the linear system whose solution set is like this. And here, this is another interesting problem that you may see in the exams. Suppose the 3 point was given, and find a parabola that passes through all these 3 points. Then from here, you can build up a linear system of equation, because each of these points satisfies this, so we can form the 3 equations like this. All you have to do is find this coefficient A0, A1, and A2, which can be done by solving the linear system of equation as we did here from the Gaussian elimination. Then you can find the A1, A2, A0, A1, and A2, which gives you the equation like this. The same problem can be applied to find the polynomial of the degree 100. If you have 101 point, then you can find the polynomial that passes through those 101 points with the same code if you just plug in the corresponding augmented matrix of the size 100 by 100. Okay. What's next? Yes, in the chapter 3 now. In chapter 3, the matrix computations. Find, when you have the different matrices, then you can find the product or addition and scalar multiplication, etc. By hand or by the code. Same thing. Compute the following if you have this. This is a matrix polynomial. I think I made yeah, I made this. Then you will see. For that matrix, A cube A square minus 13 times identity matrix is equal to 0 matrix. Actually, this gives you the concept of characteristic polynomial to find the eigenvalues of it. Okay, yeah, this tells this shows a little bit of the concept of Cayley-Hamilton theorem, because it got involved the characteristic polynomials. Here, yeah, you can compute the A transpose and A inverse, and this is a problem that shows some relationships. And yeah, you can show this if A square is equal to A. Then in this way, in two lines actually. But at the first, many of you showed it in several different ways, which has more than 10 or 15 lines, which is not quite good. This is the real proof, and this is what you have done. Yeah, you can see what he wrote in here, what you wrote in here, and you guys made it lots of computations, but actually it was not so good to show these problems. And you should be able to show a given subset of Rn is a subspace or not by using two-step subspace test. And same thing. And yeah, for many different subset of Rn, you have to do it. And also, yeah, you can determine. You should be able to find the set of. You should have a good understanding of the solution set of given homogeneous system of equations, linear equations. And yeah, you should have understanding of the properties of special matrices, definition of skew symmetric matrices, and yeah, I do not. Yes, Mr. Kang Young-hoon must do these problems once again, and Mr. Kim Won-kyung, and yeah, now we start the chapter 4, which is a determinant, and you should know the even permutation and odd permutations. And you should be able to find the determinant of the small size by hand, and also you should be able to find the determinant of a large size matrix. You should know the properties of the matrix, determinant of matrices, which is needed, and cofactor expansion is Laplace cofactor expansion is the fact that you should know, and same problems. And also you should be able to use the cofactor expansion to find the inverse matrix of the given one, cofactors. And Cramer's rule, you should know that. Yeah, actually, yeah, you already knows it. Those can be done in several ways. And similar problems, some applications of determinant is the Mandelbrot matrix and the interpolation. And this is the problem of the application of the determinant. And the same thing, area of parallelogram and volumes of parallel pipes can be obtained by computing the determinant of the matrix. And yes, this is this is an important property on the joint of the matrix. Here, this is only half a point. Actually, this fact, this is true for not only for the non-singular matrix, but also is true for the singular matrix as well. This gives the proof of this fact for non-singular matrix only. But for singular matrix, we have to show it separately because we cannot use A inverse on there. But in that case, all you have to do is show, since determinant of 0 is equal to 0, so 0 power n minus 1's power of 0 is 0. But all you have to show is the determinant of adjoint of A is equal to also 0 when determinant of A is equal to 0. So this is not really done yet. This is only half part of it. Here he mentioned. Here he mentioned. Okay, now next the characteristic polynomials and eigenvalues and bijective functions and the properties of triangular matrices. And then now we start the linear transformations, chapter 6. And we have spent lots of time, most of time on the problems in chapter 7, chapter 6, linear transformations over the last 2 weeks. So I think you are pretty well prepared on the problems in chapter 6. Since time's up, so I will finish it. If you have any questions, now it's time to ask.